Hi everyone. Some of you had requested to go over how to do a coordinate proof for similarity. So I'm going to show you how to use SAS similarity to prove that triangle EHJ is similar to triangle EFG. So meaning the small triangle here is similar to the big triangle. Okay, so it's a proof, so you know they're similar. You just have to show your work. It's a little different than a formal proof where you write a statement and a reason. You're basically proving by showing your work. So the first thing I'm going to do is I'm going to say that angle E is congruent to angle E. And this is by the reflexive property. So they share that angle, so therefore I can say it's congruent to itself by the reflexive property. Now, what I want to do is prove that the corresponding sides are in the same proportion. So in order to do that, I need to know the length of the sides. I'm going to have to find the length of EF, EH, EG, and EJ. So first, let's find the lengths of EF and EH. I'm going to use the Pythagorean theorem to do this because I can just count the boxes and then plug into the formula a squared plus b squared equals c squared. Let's start with EF. This is one box. This is 1, 2, 3, 4 boxes. So 1 squared plus 4 squared is equal to, we'll say, EF squared. Okay. 1 squared is 1. 4 squared is 16. 1 plus 16 is 17, equal to EF squared. So you're going to take the square root of both sides. So the square root of 17 is equal to EF. And I'm going to leave it as square root of 17. I'm not going to change it. Okay, now I'm going to find the length of EH the same way. So here we have 2 boxes, and here we have 1, 2, 3, 4, 5, 6, 7, 8 boxes. So I would say 2 squared plus 8 squared equals EH squared. 2 squared is 4. 8 squared is 64. 4 plus 64 is 68. We take the square root of both sides. Give me the square root of 68 equals EH. Okay. Now I'm going to find the lengths of the other 2 sides the same way. So if you want at this point, you can do this on your own, or you could stay with me. So again, I'm going to draw my dashed lines. This is 4 boxes. This is also 4 boxes. And then for the bigger triangle, we have 4, 8 boxes, and 2, 4, 6, 8 boxes. Alright, so for the small triangle, it would be 4 squared plus 4 squared equals EG squared. So the square root of 32 is equal to EG. And then for this other one, it would be 8 squared plus 8 squared equals EJ squared. Alright, so now I have all my side lengths. I'm just going to show that the corresponding sides are proportional. So the corresponding sides would be EF and EH. So I say the square root of 17 over the square root of 68. And this should be equal to EG over EJ. So the square root of 32 over the square root of 128. Now I'm just going to use my calculator. The square root of 17 divided by the square root of 68 is 0.5 or 1 over 2, a half. And then this one should show me the same thing because we know that these are proportional. We know these are similar. We're just proving it. And yes, you see it's the same. So that's really all you have to do. And then just maybe say corresponding sides are proportional. And then your last but not least, you always want to say your prove statement and what the reason is for that. So EHJ is similar to EFG by SAS similarity. So again, just to recap really briefly, first, I'm saying that angle E is congruent to angle E by the reflexive property. Then I have to prove that the sides on either side of angle E are proportional. So I find the distance of each side by using the Pythagorean theorem. I match up like the small side to the big side for the corresponding sides, reduce, and that shows me that the corresponding sides are proportional. So therefore we have SAS. We can prove that triangle EHJ is similar to triangle EFG by the side angle side similarity postulate. Sorry, side angle side similarity. I don't know if it's a postulate. Let me know if you have any questions. I can make another video if you need me to, or we can check in on Zoom next week. Have a good night.